All the substances in the world can be classified into groups. All groups represent the physical forms in which that substance can exist. One way to group substances is into three categories: solids, like this ice; liquids, like this water; and gas, like this water vapor coming out of the boiling pot. This video will investigate the particle movement out of these three phases of matter, and we'll also get into a fourth state of matter called plasma. Hope you enjoy.
Okay, so matter is going to be made up of tiny particles called atoms and molecules, and we'll get into more depth on what atoms and molecules exactly are. This section is going to refer to atoms and molecules with a generic term called particles, and these particles are going to be too small to see without a very high-powered microscope. And if you can imagine that these particles and substances are tiny balls, they're going to be moving, they're always going to be vibrating, okay? And they're bumping into each other all the time. So the first type of state of matter that we're going to focus on is solids. And you can see the picture, the little balls, they are actually vibrating in place, if you can imagine, and they're kind of bumping off of each other, but they're staying in place. Solids have a definite shape and a definite volume, meaning you can't really change the shape of the solid unless you're going to melt it, but then that would change the state. So we're just talking about solids. They have a definite shape and a definite volume. Also, they're not going to flow, since they're staying still, staying together, and they're not going to flow. And you can't compress them, meaning you can't squeeze them. There's two categories for solids. There's crystalline and amorphous. A crystalline solid is going to have all those little tiny balls in the solid particle aligned in rows in some kind of pattern, three-dimensional arrangement of the pattern of the particles, and it's going to be repeating. Iron would be an example of this. Diamonds would be an example of this. Ice would be an example. Like an aluminum baseball bat would be an example. Stuff that's very orderly. The molecules are going to be very orderly. Versus amorphous. Amorphous is going to mean that the particles do not have a special arrangement. So each particle is in one place, but the particles are not arranged in a pattern. An example for amorphous solids are going to be like glass is amorphous, rubber, wax. So two different categories, and it has to deal with how the particles are arranged. The next category or state of matter is going to be liquids. Now this is going to be a little bit different. The particles are still vibrating in place, but what's going to happen is you're going to have a shifting shape, meaning that the liquid can take the shape of its container. So it can flow. There's no particular shape that a liquid has to be in, as opposed to a solid. But the key thing is that you cannot compress a liquid, meaning if you had 10 milliliters of a liquid, you're always going to have 10 milliliters of a liquid. You can't compress it at all. You can't squeeze it. Liquids have the properties of surface tension and viscosity. Surface tension is going to be the force that makes the particles in a liquid stick together. It causes liquids to form spherical drops, like beads of water on like a grass blade. We're going to do a fun little mini lab with, I'm sure you've done it before, where you try to drop water on the head of a penny and see how many drops it can form. But it's cool because you get to see how the liquid forms a bubble on top. And that stickiness is surface tension, and only liquids have that property. Solids and gases do not have that property. And another property for liquids is viscosity. And viscosity is going to be the resistance to flow, a liquid's resistance to flow. And the stronger the attraction between the molecules of a liquid, the more viscous it's going to be. So what would have high viscosity? Honey would have high viscosity. Molasses, for like gingerbread cookies. Syrup would have really high viscosity. What would not have high viscosity? So what would mean lower viscosity would mean that the molecules aren't quite as attracted to each other. Low viscosity would be like water. Water's kind of like your low viscosity, and then as you go up, like oils, then you get into honey, and then high viscosity would be syrup and molasses. So water would have a very low viscosity. The last category of for our states of matter is going to be gas. Gases are interesting because their particles are kind of spread out. You notice in the picture that the particles have gotten more and more spread out. They're going to be moving kind of more violently because we're talking about higher temperatures with these particles. They have shifting shapes, which means you could take gases and you can push them into any shape that you want. And they have shifting volumes too. They can flow pretty easily like a liquid, but the thing that separates them from a liquid is that you can actually compress a gas. They take the shape of its container. Imagine like a scuba tank. I'm going to put oxygen in that scuba tank and I'm going to compress it down, push it down. All of these particles are shaking, the solid, the liquid, the gas. They are kind of vibrating in place. There's a term called absolute zero, and it's a theory, so it's not totally proven, but it's the idea that if we can get these particles so cold, so really, really into their solid phase, but get them really, really cold, that eventually the particles will stop moving. And that's a theory because all particles are going to be moving. So if you go towards the left of my page from gas to liquid to solid, the particles are getting tighter together and they're vibrating. They're not vibrating as violently like gas. They're going to be vibrating more violently. They're not going to be vibrating as violently, but they are still vibrating. And the idea of absolute zero is that the particles would stop vibrating because they'd be so cold that that would be the absolute lowest temperature you can get. That's a theory. You really can't test that because if you tried to take a substance and freeze it down and try to get its particles to stop vibrating in place, they're still going to be picking up heat from the object that they're sitting on. Maybe it's the table, and that table, is sitting on the earth, and the earth has heat. So heat's always going to be like put into the substance, so you're never going to have a situation where the particles are going to stop moving. But that's the idea. Absolute zero would be where the particles stop moving. You can't really have that though, but that's kind of an idea of if you got it cold enough, the particles would stop shaking. There is one other state of matter after gas, and that's called plasma. And in the plasma state, the particles are shaking very violently and they're very, very spread out. So it's kind of like gas, but those particles are spaced even further apart. Plasma, your examples would be like fire, or the sun has plasma. Aurora borealis, which is the northern lights. If you've ever seen the northern lights, that's plasma in the universe. And that's the really, really high state of matter. We're never going to really play around with it in our lab, but I wanted to throw that out, that there is one other state of matter and it's called plasma.